This week we're going to use a point request to get a time series from the GFS. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to start pulling some data from the GFS to get a time series. We've looked at getting different variables over a spatial range, but we actually want a specific point on the surface of the Earth and to get multiple times for that. So we could do something like build a mediogram. So I'm going to start out from siphon.catalog, import the threads data server catalog object. And we've talked about using the threads data server catalog before, and in fact, relatively recently, as we've done some declarative plotting in the last few weeks. So I'm going to go to the threads test data server and get the URL for the half-degree GFS. Change that to XML. We can remind ourselves what datasets are available. In this case, I'm going to use the full collection. And then I'm going to create a subset object to make my netcdf subset service request on. Without pulling any data, I can go ahead and look at the variables that are available to me. So I'm going to look through here. There's some pressures, relative humidities, temperatures. Temperature surface is probably the variable that we're going to want for a mediogram. So I'm going to create a query by calling ncss.query. I'm going to accept a netcdf4 data return. The variable, or variables, we're going to get temperature surface for now. And we want a lon lat point. I'm going to do negative 97.330 for my longitude and 37.687 for my latitude, which is somewhere in the neighborhood of Wichita, Kansas. And then our data is going to be ncss.getData, given our query object. That will actually go out and get the data from the threads data server. If we look at the data variables that are available to us, we see we had lat and lon, altitude, ID, etc. get added in. Time and temperature surface are what we're namely going to be interested in here. So we know that we're probably going to have to convert temperatures because most models are going to output temperatures in Kelvin. And the time, we've seen this before, it's going to be in hours since some reference time. So we're going to need to use num to date to convert that. So for metpy.units, we're going to import the units registry. And then from netcdf4, I'm going to import num to date. I'm going to go ahead and create a variable for my times using num to date. I'm going to get my time variable, get all of the data from it. On my time variable, I'm going to get the units, which will be something like hours since January X 2023. And then I'm going to force it to only use Python date times to be true, and only use CF time date times to be false, because I want to be sure I get a Python datetime object that I can easily use for plotting. And now if we look at time, we get these real date times starting January 1st and proceeding down to the 17th in this case. All right, and so lastly, we can make a plot. So we're going to import matplotlib.pyplot as PLT. And of course, the quick dirty plot would be to just call plt.plot data temperature surface. And we just want the data from that masked array. As expected, we're going to be getting things in Kelvin, it looks like. So we're going to want to convert that. And hours since an arbitrary date in January is not incredibly useful, so we're going to do a real time plot as well. So first, let's take care of the temperature. It's going to be getting our surface temperature data, multiplying that by units so we become unit aware. And then I'm going to convert it to degrees Fahrenheit, since that's what we're used to looking at a surface forecast in here. I'm going to import matplotlib.dates as mdates to improve the look of our formatters a little bit. And we'll go ahead and plot time and temperature. I'm going to get the x-axis object and call set major locator to mdates.dayLocator. So we'll put a major tick mark every day. Set minor locator. It's going to be mdates.hourLocator, but I don't want one every hour. I just want 0, 6, 12, and 18 minor tick marks. And finally, so we don't try to plot the whole year, month, day, hour on every tick mark, we're going to set the major formatter to be mdates.concise-date formatter. And we're going to pass that the major locators. And once we do that, we get a plot that has nicely the year down here in Jan, and then we've got each day in this particular GFS data set and a tick mark every 6 hours labeled nicely, so we can see our nice diurnal variation and the warm-up that is expected here in mid-January. I hope that you found this useful, and I'll see you on next week's MetPy Monday.